Okay, on number 6, it says the position equation for the movement of a particle is given by S of t equals 2t squared plus 3, all to the second power, where S is measured in feet and t is measured in seconds. Find the acceleration of this particle at 2 seconds. Remember, acceleration is your second derivative. So basically, the first thing we got to do is we got to take this equation right here, and we got to find its second derivative. So since this is just being squared, the easiest way to do this one is just go ahead and FOIL it out. Since I have to find the second derivative, you can go ahead and FOIL this out and do first outside, inside, last. And now when it's changed, it's a lot easier to find the derivative. So remember to FOIL this out. You're going to have to go ahead and write this equation twice. You can do that mentally, or you can actually write it out. So I'm going to just write down 2t squared plus 3 times 2t squared plus 3. And notice now when I go ahead and find my first, that's 2t squared times 2t squared. That's going to be 4t to the fourth. Outsides, in this problem right here, is going to be 2t squared times 3, which is 6t squared. Insides is 3 times 2t squared, which is also 6t squared. And when I take 6t squared plus 6t squared, I'm going to get 12t squared. Now my lasts, we got a 3 times a 3, which is going to be 9. Now that I've done that, I can just go ahead and apply the general power rule to find the second derivative. So to find the second derivative, I go ahead and take the derivative of 4t to the fourth. So remember, to find that derivative, you're going to take 4 times 4, which is going to be 16, and then you're going to subtract 1 from 4, and you're going to get t to the third. Go to 12t squared, I'm going to take 2 times 12, and I get 24, and I subtract 1 from 2, and I'm going to get t to the first. And now the derivative of 9 is just going to be 0, so you don't see it there. So the first derivative of that equation is going to be (16t cubed plus 24t). That is also known as your velocity. So if I asked for velocity, I'd stop right there and substitute in. But it didn't. It asked for acceleration. So now I got to find the derivative of my velocity equation. So you'll notice I write that as v of t to stand for velocity. Now I'm going to go ahead and find the derivative of 16t cubed. So I'm going to take 3 times 16, which is going to be 48. And then I'm going to subtract 1 from my 3. So that's going to be t squared. And then I take the derivative of 24t, and the derivative of 24t is just going to be 24. You're going to notice with this equation right here, that is your acceleration equation. So I use a of t to represent that. That's the second derivative, which is acceleration. Now that I've done that, I'm ready to go ahead and answer the question. And the question that it posed is, it said, you're going to notice it says, find the acceleration of this particle at 2 seconds. So notice, at 2 seconds, all I have to do to find that now is just go ahead and substitute in 2 into my equation. So when I do that, I'm going to take 2 and square it. So that's going to be 4. And then I'm going to take 48 times 4. And 48 times 4 is 216. So notice how it's written. So the acceleration at 2 seconds is 216 feet per second squared. Okay, on number 7. This says find dy dx of the following equation. So to find dy dx of the following equation, just remember that dy dx means find the first derivative. In other words, differentiate it. But in this case here, we've got to go ahead and use implicit differentiation. So notice with this equation here, I've got to take the derivative of y cubed. So the derivative of y cubed is going to be 3y squared. So I multiply the 3 out front, and then I subtract 1 from it. Well, notice with implicit differentiation, you either have to write y prime or dy dx next to every single time that you differentiate a y. In this case, I just went ahead and wrote dy dx, so I'm using Leibniz notation. Now the next one says that I want to go ahead and find the derivative of, and then it says negative 3y squared. So to find the derivative of negative 3y squared, you're going to take this 2 times negative 3, and you're going to get negative 6, and then you're going to subtract 1, and you're going to get negative 6y. And then since I just differentiated a y, I'm going to write dy dx. Now I go ahead and find the derivative of 2x. So the derivative of this 2x right here. Just multiplying the 2 out in front, subtracting 1. So that's going to give me a plus 2x. And then the derivative of 5 is 0. Now that I've done that, remember to go ahead and put your dy dx or your y prime on one side of your equal sign and everything else on the other side. That's my next step. So I go ahead and I subtract this 2x from both sides. And when I subtract the 2x from both sides, I'm going to get that negative 2x. And then we'll notice I still have on this side my 3y squared minus 6y, and both those have the dy dx next to them. So now I'm going to go ahead and factor out dy dx. And when I factor out dy dx, goes out in front, and I'm going to be left with the equation 3y squared, because 3y squared divided by dy dx is just going to leave me with the 3y squared. And then when I take the dy dx out of this term, I'm just left with negative 6y. Now that I've done that, I'm ready to go ahead and divide both sides by 3y squared minus 6y. So I'm going to divide this side by 3y squared minus 6y. And when I do that, I'm going to be left with dy dx all equals negative 2x all over 3y squared minus 6y. Now number 8 says go ahead and find y prime of the following equation. So notice to find y prime, that means find the first derivative. So to find this first derivative, so here's y. First derivative is y prime. So now I have to use the chain rule combined with the product rule. Because you're going to notice I've got the outer equation, and then I've got the inner equation. And that inner equation is an equation times an equation, which means I have to use the product rule. When I take this derivative of this outer equation right here, the sine of xy, well, the sine derivative of the sine is just going to be the cosine, so I got the cosine of xy. And then when I take the derivative of this inner equation right here, remember that's an equation times an equation. So I'm going to go ahead and take the derivative of the first term. So the derivative of x is just going to be 1. I leave the second equation the same, so that's going to be y. I've got plus, I'm going to go ahead and leave the first equation the same, x, and then when I take the derivative of the second equation, I get a 1, but I just differentiated a y, so I have to write y prime. So remember, this is a combination of the product rule with, the chain rule with the product rule. Now that I've done that, I go ahead and simplify this down a little bit to make it a little bit nicer. So 1 times y is just y. And then I just write down my plus xy prime. Because you're going to notice what you have to do on this next step is you're going to have to distribute this. Because this is the cosine of x plus y out front times y and times xy prime. So when I do that, and I multiply this one to the first one, you're going to notice I'm going to be left with y cosine of xy. And just get in the habit of always writing your algebra first. And then when I multiply it by the second one, you're going to notice that this cosine of xy times xy prime, so I'm multiplying this and this together. This is going to give me, when I write my algebra first, xy prime times the cosine of xy. Now the reason why I had to do that is because I had this y prime right here and this y prime right here. And since I just did implicit differentiation, I've got to combine those two together. So when I combine those two together, my next step is go ahead and take this xy prime cosine of xy, and I have to move it over here next to the y prime so that I can go ahead and factor it. So now notice I do that by subtracting this whole entire term from both sides, minus xy prime cosine of xy. And now I end up with y prime minus xy prime cosine of xy, and I got y cosine of xy. Now that I've done that, I can go ahead and factor that y prime out and then divide. So I'm going to factor out this common y prime in both terms. And so when I factor it out, y prime comes out first. And then on this one, I'm going to be left with a 1. And then on this one right here, I'm just going to be left with x cosine of xy. Now that you've done that, you're ready to divide both sides by, now 1 minus cosine x cosine of xy, so I'm going to divide this side by 1 minus x cosine of xy, and divide this side by 1 minus cosine of xy. And when you do that, you get your derivative of y prime equals y cosine of xy all over 1 minus x cosine of xy. On number 9, the directions just tell you on number 9 it says differentiate. So differentiate just means find the first derivative. So first thing I'm going to do is I notice that I've got y equals the cosecant squared of x plus cotangent squared of x. I want to rewrite this so it's easier to recognize the outer and the inner equation. So I rewrite this as cosecant of x all to the second power, putting parentheses here, and the cotangent of x all to the second power, putting parentheses right there. That'll help me to recognize that I've actually got outer equations and inner equations, and I have to go ahead and use the chain rule on. I need to remember also that the cosecant of x, its derivative is negative cosecant of x, cotangent of x, and the derivative of the cotangent of x is going to be the negative cosecant squared of x. So here's my outer equation right here. My outer equation says take 2 multiplied out front, and you're going to notice that's going to be 2 cosecant of x, subtract 1. So that's 2 cosecant of x to the first power. And then I got to take the derivative of what's inside. So the derivative of what's inside is the derivative of the cosecant of x. And I just remember the derivative of the cosecant of x is going to be negative cosecant of x, cotangent of x. And now to find the derivative of this cotangent of x to the second power. Remember, here's your outer equation. You're going to take 2 multiplied out front. So you're going to get 2 cotangent of x, and you're going to subtract 1 to get to the first power. And then you got to take the derivative of what's inside. So the derivative of what's inside, or the derivative of the cotangent of x, something you have to memorize, is going to be negative cosecant squared of x. So remember, the chain rule says the derivative of the outer equation times the derivative of the inner equation. Now I'm going to go ahead and simplify this down as much as possible. So notice this 1, you don't really have to write it, but this negative and this 2, they're going to go out front, negative 2, because that's your algebra. Now you're going to take the cosecant of x times cosecant of x, and that's going to give you the cosecant squared of x, and then you still have the cotangent of x. And then you've got, again, a negative 2 positive, so that's going to take that negative 2 out front. And now I have the cosecant squared of x, so cosecant squared of x, and then cotangent of x. And remember that 1 is just a single cotangent of x. Now the reason why I wrote it that way is because now I can recognize that this is actually a common term. So this term and this term are alike. So now I'm just going to take negative 2 minus 2. I'm going to get negative 4. And you got the cosecant squared of x, cotangent of x. On number 10, we've got the cosine cubed of 4x. So I'll rewrite this as cosine of 4x all to the third power. That's what I did right here. So I wrote that as the cosine of 4x all to the third power because that's what that means. But now notice you've got the chain rule and you've got several things inside of here. And so you're going to notice you've got your outer equation, which is this whole entire thing. The outer equation, you're going to take 3 times the cosine of 4x, and then you're going to subtract 1 from your power, and you're going to get squared. Now we got this next inner equation right here. This next inner equation is the cosine of 4x. And when I take the derivative of the cosine of 4x, well, that's just going to be negative sine of 4x. And then I've got my next equation inside of that, which is 4x, and the derivative of 4x is just going to be 4. So now that I've done that, doing my algebra and just combining my algebra together. So notice I've got a 4 right here. I've got a negative sign right here. And I've got a 3 right here. So that's going to be negative 12. Notice this cosine of 4x squared. You can leave it like that. But typically the book changes it back to its other form. So that's this cosine squared of 4x. Just a reminder, this is the same thing. And then you still have your sine of 4x right here. And that whole entire thing is going to be your answer. So your answer is going to be -12 cosine squared of 4x times the sine of 4x.